sector is so hard. Fatima, do you know about the issues of radioactivity in Malaysia? Issue? Radioactivity? Do you know? That's a long story. Let's go.
Hi. Hi.
Hi. Hello.
Hi.
So today I would like to explain about issues that relate to radioactivity, monitoring and safety in Malaysia. First, the Malaysia government plans to add 4 more stations for the gamma spectrum water monitoring or TISF26. These stations are used for monitor level of radioactivity in Malaysia's water. Their purpose is to detect any radioactivity contamination early to ensure the safety of environment public health. Next, Malaysia is also conducting training exercise with Asian countries to prevent the smuggling of radioactivity material. This training helps authorities improve cooperation and preparedness in detecting, controlling illegal movement of radioactivity substances that could threaten national security. Another issue that has received attention is related to Lynas rare earth processing plant in Malaysia. This plant processes rare earth material that are used in modern technology such as smartphones, batteries, and electronic devices. However, the operation of plant processing has become controversial because contain radioactivity element. Some groups are concerned that the waste could affect the environment and the health of nearby community if it is not properly managed. In conclusion, these issues show that monitoring and managing radioactive material is very important to ensure environment safety and protect public health in Malaysia.
So as you can already hear the issue from Aida, so how do we avoid radioactivity? Actually, we can completely avoid it. That's because radioactivity is naturally part of our environment. Every day we are exposed to small amount of natural radiation. For example, radiation can come from our own bodies, the food we eat, rocks, salt, and even the air around us. But don't worry, these are very low levels of radiation, and they are generally harmless to humans. Because of that, radioactivity shouldn't always be seen as something scary. In fact, since its discovery, radioactivity has helped us in many important ways. It is used in things like radioactive traces, sterilizing food, and even generating electricity. And honestly, the list of its benefits keeps growing. So instead of being afraid of radioactivity, maybe we should try to understand it better and break the science wall. When we understand it, we can actually use it to create even greater innovation in the future. For example, radioactivity has many useful applications in our daily life. In medicine, radioactive materials are used in radiotherapy to treat cancer and also in medical imaging such as PET scans to help doctors diagnose disease. In industry, radiation can help detect leaks in pipelines and measure the thickness of materials during manufacturing. In agriculture, scientists use radiation to create crops that are more resistant to pests and disease. And in archaeology and geology, radioactive isotopes like carbon-14 help scientists determine the age of fossils, rocks, and historical artifacts. As you can see, radioactivity is not just a scientific concept. It is actually something that helps improve many aspects of our lives. Besides the risk, radioactivity has contributed greatly to human development, from medicine and food safety to electricity generation and even space exploration. Radioactivity continues to play an important role in improving our lives and advancing scientific discoveries.
In radioactivity, we have half-life, which is the time taken for a radioactive substance to decay to half of its original amount. It is predictable, and this is one of the factors that makes radioactivity useful in many fields. Radiation has 3 main types of radiation. First, we have alpha particles. Alpha particles are relatively light and heavy. They travel only a short distance and can be stopped by pepper or heuristic. Second, we have beta particles. Beta particles are smaller and more faster. They can travel further than alpha particles and can be stopped by thin metals such as aluminum. And the last one, we have gamma rays. Gamma rays are very energetic electromagnetic waves. They can travel very far and require dense materials such as lead or concrete to reduce or block them. some radioactive atoms change directly into stable atoms, while others change into new radioactive atoms. This process creates decay chains, which conduce until a stable atom is formed. Another important concept is ionizing radiation. Ionizing radiation is radiation that can remove electrons from atoms, creating chains particularly called ions. Ionizing can alter molecules and biological materials, which is why scientists pay close attention to radiation exposure. Although individual radioactive decays are unpredictable, large groups of atoms behave in renewable and measurable ways. This allows scientists to measure, monitor, and manage radioactive materials safely. So this is some of examples of radioactive elements. First we have uranium, especially uranium-235 and uranium-238. This is used in nuclear reactors and nuclear energy production. Another example is radium-226, which was once used in luminous paints and medical treatment. Lastly, carbon-40 is widely used in carbon dating to determine the age of ancient fossil and archaeological artifacts.
A fun fact is that bananas are actually slightly radioactive because they contain potassium-40, but the radiation level is extremely small, so it is completely safe to eat. Surprisingly, our own bodies are also slightly radioactive because they contain small amounts of radioactive elements like carbon-40 and potassium-40. So, radioactivity is not just something that occurs. In fact, it exists all around us, even in bananas and in our own bodies.
In conclusion, radioactivity is a natural process where unstable nuclear atoms release energy to become more stable. Although it can pose risks itself, when used carefully and responsibly, radioactivity provides many important benefits in medicine, industry, agriculture, and scientific research. Therefore, understanding radioactivity helps us use this powerful technology safely and effectively.
That's the story about radioactivity. Now you understand? So now I know. Thank you, Ada, for explaining to me.
It's not a big day, bro.